Good morning. I'm Padmapriya, Assistant Professor in Department of CSE, RMD Engineering College. Today, we are going to see a topic on IPv4, the header format of IPv4 under the subject 21CS 501 Computer Networks. Internet Protocol version 4, IPv4. IP is a main protocol which is responsible for packetizing, forwarding, and delivery of a packet at network layer. The IP is an unreliable datagram protocol which provides a best effort delivery service. The term best effort means that the packets can be corrupted, be lost, or arrive out of order. If reliability is important, IP must be paired with the TCP, which is a reliable transport layer protocol. IP is a connectionless protocol. It uses the datagram approach, where each datagram is handled independently. Each datagram can follow a different route to the destination. Datagrams may arrive out of order at the destination. Packets used by the IP are called datagrams. A datagram is a variable length packet consisting of two parts, header and payload data. The header is 20 to 60 bytes in length and contains information essential to routing and delivery. This is the packet format of IPv4. The first layer gives you version, which is of 4 bits, header length, which is of 4 bits, service type, which is of 8 bits, and remaining total length of the data, which is of 16 bits. The next layer gives the identification of the IPv4 packet, which is of 16 bits, followed by flags of 3 bits and fragmentation offset of 13 bits. The next layer is time to live TTL, which is of 8 bits, followed by protocol, which is of 8 bits, and header checksum, which is of 16 bits. Followed by the next layer is of source IP address of 32 bits and followed by destination IP address of 32 bits, which is then followed by the data, which is of 0 to 40 bytes, which gives you the IPv4 packet format. Here, the header is going to be of 32 bits, which is be followed by payload. The header can be of 20 to 60 bytes, that is 20 to 65,535 bytes, which is being followed by the data payload. Now let us see these fields in detail. The IP datagram, like most packets, consists of a header which is being followed by a number of bytes of data. The first field is version. The version field specifies the version of IP, and the current version of IP is 4, and it's sometimes called as IPv4. Next field is header length. The header length specifies the length of the header in 32 bits words. When there are no options, which is of most of the time, the header is 5 words, that is 20 bytes long. The next field is TOS, that is type of service, which is of 8 bits. This field determines whether or not a packet should be placed in a special queue that receives load delay. Length. The next 16 bits of the header contain the length of the datagram, including the header. Unlike the header length field, the length field counts bytes rather than the words. Thus, the maximum size of an IP datagram is 65,535 bytes. The next field is time to live, TTL. This field indicates amount of time the packet is allowed to remain in the network. If TTL becomes 0 before the packet reaches the destination, the router discards the packet and sends an error message back to the source. The value 64 is the current default. Identification field. This field allows the destination host to determine which datagram a newly arrived fragment belongs to. All the fragments of a datagram contain the same identification value. Flags, DF and MF. So these are the two fields which are there in the flags. TF means don't fragment, MF means more fragment. If the Ethernet packet is being a fragmented packet, then the MF field is going to be set as 1. If it is going to be a whole packet, the TF field is going to be set as 1. Offset. So the offset is going to indicate the next fragment piece of the data which is being followed, and the starting header length of that particular offset value is going to be given here. Maximum 8,192 fragment per datagram can be allowed. Protocol. This field is simply a demultiplexing key that identifies the higher level protocol to which this IP packet should be passed. Checksum. This field is used to detect transmission errors. Next comes the source and destination addresses. These 32-bit source and destination address fields define the IP address of the source and destination respectively. The source host should know its IP address. The source address is required to allow the recipients to decide if they want to accept the packet and to enable them to reply. The destination IP address is either known by the protocol that uses the service of IP or is provided by the DNS. Options. A datagram header can have up to 40 bytes of options. Options can be used for network testing and debugging. Although options are not a required part of the IP header, option processing is required of the IP software. This means that all the implementations must be able to handle options if they are present in the header. Followed by payload. Payload is the data which is the main reason for creating a datagram. It is the packet coming from other protocols that use the service of IP. Comparing a datagram to a postal package, payload is the content of the package. The header is the only information written on the package. Thank you.